Hello, this is my Module 12 discussion, and I will begin by reading the research question that we are looking at for this week. And it says, how well can we predict a student's score on the final exam based on their performance in the class from the first 13 weeks of the semester? So I started out, so we have the quiz, information or statistics, and then discussion, and then exam. So I start out with the null hypothesis, as quiz scores do not predict a student's score on the final exam based on their performance in the class from the first 13 weeks of the semester. So it does not equal 0. And then the alternative hypothesis is the quiz scores do predict a student's score on the final exam based on their performance in the class from the first 13 weeks of the semester, and that does equal 0. And then the conditions and assumptions. So I would say these are independent. So like the quiz score doesn't influence the discussion score in a way or to a certain extent. And then I would, even though it wasn't said, I would say that this was a random sample that was drawn because it's taken over the past semester. So it could have been from a couple years ago or even last year. And then the 10% of the 10% condition, so there's no more than 10% of the population in this study. So for my the t-test, I got 6.9, and then I included the equation, or I did the equation through Excel and got 3.85 for my p-value, and I ended up failing to reject the null hypothesis or retaining it because of the p-value. So I came to the conclusion that the quiz scores cannot predict a student's score on the final exam. And then for the discussion section, I got a t-test of 3.98 and then the p-value of 0.0001, and I chose to reject the null hypothesis. And I said that the discussion scores can possibly predict a student's score on the final exam. And then for the exam portion, I got a t-test of 9.54, which led me to the p-value of 8.61. And then my decision was to fail to reject the null hypothesis or retain it. And my conclusion was that the three exams cannot predict the final score. And then for part 2, I chose to do Reg 2, which included exam 1 through 3 and then quiz 1 through 10. So my 95% interval included the coefficient and then plus or minus the number I got from the t-table. So I looked at the degrees of freedom, which was 79, or 80 minus 1 is 79, and then also the 95% confidence interval, which was 1.990, and then I multiplied that by I multiplied that by the standard error of the quiz. So I got 0.33 and then negative 0.26. And then I just said that we could reject the null hypothesis or retain it because 0 is in this confidence interval. And then for the exam 1 through 3, I did 0.7986, which was the coefficient, plus or minus the confidence interval from the t-table, and then multiplied that by the standard error from the exam 1 through 3. And then that was between 0.53 and 1.06, and then I said to fail to reject the null hypothesis because 0 was not involved in this confidence interval. And then for part 3, we can go to Reg 4, which includes all the data. And so for the distance or the variability of R squared, or the discussion, is 0.17 or 0.17, and then the distance or variability between the discussion exam subtracted by the exam was 0.17, and then the distance or variability of discussion, exam, quiz subtracted by exam and the quiz, I got 0.32, and this is just saying kind of like the difference or how different they are from each other, or the R squared value. And then for part 4, I would just say that The variety is just saying that it depends on, like, I guess maybe like this how much the student studies, or I think it does depend on past exams and quizzes and discussions as a whole too. But yeah, that's it. Thank you.